is scarce. Hi, I'm Mr. Chongo, and welcome to our first lesson, 1.4, Properties of Exponents. Let's get started. Right. So, in this particular section, there are three words that are important for you to know. The first one is power, exponent, and base. So, basically, when I write an expression in this form, some of you will probably remember or know that this means that I'm multiplying 4 to itself. How many times? Twice. This expression written in this form is what we call a power. Then we have a number here at the top that tells us how many times 4 should be multiplied to itself. This is what we call an exponent. Then you also have your 4, which is the bottom number that you're going to multiply how many times the exponent tells you to. And that's what we call the base. Knowing that, we're going to look at some properties of exponents. There are a few of them, so we're going to do our best here to look at one at a time. We start with the zero exponent property. The zero exponent property basically says, well, when you take anything, any term and raise it to an exponent 0, that's just 1. So an example here in numbers would be if I said 4 to the exponent 0, that would just simplify to 1. Even the biggest number that you can think of, for example, 1,000, when the exponent is 0 to that number, it's just going to simplify to 1. And that's what we mean by the zero exponent property. Let's move on to the next one. The next property is the negative exponent. And here we mean that, well, an exponent is a negative in this case. And so how we simplify this is ends up being or having a positive exponent. We write it's 1 over a to the exponent n. In this case, notice how n is positive now because of the change that we again apply to this expression. So another way you can think of it is taking the 1, just to help you remember this, turn it so it becomes your 1 and your numerator, and then what you're going to have left at the bottom as your numerator will be the positive term or the positive power. An example with numbers here would be, let's say 4 to the exponent negative 2. Again, this will just simplify to 1 over 4 to the exponent 2. Okay. Moving on to the next one, product of powers property. Again, we take two powers and we're multiplying them. In this case, notice how the bases are the same. These two are exponents, but the bases are the same. And I like to indicate that again, just to remind you that we have the same bases. When that's the case, well, to simplify this, we'll just take one of the bases and do what to the exponents? Well, we're going to add them. So when you're multiplying powers that have the same bases, you simply add the exponents. I can combine those exponents. They're not like terms, so I'm going to leave it as it is. But if we had an example here with numbers where, let's say we have 4 to the exponent 3, that's a power, and then another power for the exponent 2, then because I'm multiplying powers that have the same base, I can then write 4 to the exponent. In this case, I'll add the powers, and when I simplify the powers, I end up with 4 to the 5th power. Okay? Moving on, we have a quotient of powers property. Again, we have two powers that we're dividing. So in this case, we'll actually take one of the bases if they are the same, which they are in this case, and the opposite of what we did previously, we were adding them. Here we're going to subtract, so it would be m minus n. I can combine those, so I'll leave it as it is. But as an example, we could have 4 to the 5th power over 4 to the 3rd power, and this would have to simplify to the same base, and then you